Hello and welcome to this tutorial. In this tutorial, we're going to be looking at quadratic inequality in one variable. By taking this tutorial, I'm assuming you're already used to the concept of inequality and also the concept of quadratic expression. So if you're not used to that, feel free to check any of our tutorials under quadratic equation and also inequality. So in this tutorial, we shall attempt to find the solution to the set of quadratic inequality of the form ax squared plus bx plus c greater than or equal to 0, or ax squared plus bx plus c less than or equal to 0. So from these two expressions, we can see this, which represents the general form of quadratic equation, and also the positive greater than or equal to or less than or equal to that represents inequality. So we shall be looking at three different methods that we can use to solve this form of equation. So let's get started with the first method. We can simply call the first method analytical method. So method 1 of solving quadratic inequality in one variable. And we are going to be looking at some analysis to draw out conclusions to solve our quadratic inequality. So the first scenario that we are going to be looking at is if we have two expressions. If you have a multiplied by b and this is greater than 0. So then we have some conditions that must be satisfied for this to be true. So then either, so take note of this. So the first condition for this to be true is that a can be greater than 0 and also b greater than 0. So for this to be true, for us to have a multiplied by b greater than 0, so it's either a is greater than 0 and also b greater than 0, or so we can have a less than 0 and also b less than 0. So for a multiplied by b to be greater than 0, we must have either a to be greater than 0 and also b to be greater than 0, or a to be less than 0 and also b to be less than 0. So if you have a greater than 0 and b equal to 0, this is going to be equal to 0. So our condition will not be satisfied. So that's the first point. So the second point is if you are considering the less than symbol. If you have a again multiplied by b to be less than 0, again then either, so we also have two conditions here. So the first one says that a is less than 0 and b is greater than 0, or we have the first case, we have a greater than 0 and b less than 0. And this quite makes a lot of sense if you try to analyze these two expressions. So for us to have a multiplied by b less than 0, so then we have one of the expression must be less than 0. For example, if you have, let's say for example, we have in this case a to be equal to 2 and b to be equal to 3. So if you multiply a times b, in this case 2 times 3, so we are going to have 6. So here we have a multiplied by b to be greater than 0. As you can see here, we have a to be greater than 0, which is 2, and also b to be greater than 0. So in this case, we have a multiplied by b to be equal to 6. So and also if you have to consider the second condition, so if you have a in this case to be negative 2 and b to be equal to negative 3. Again, if you have negative 2 multiplied by negative 3, you are going to have 6. So if either of these conditions is satisfied, we always have a multiplied by b to be greater than 0. So if you look at the second condition, for us to have a multiplied by b less than 0, then either a is less than 0 and b is greater than 0. So for example, you can have a, if a is less than 0, you can have a to be negative 2 and b to be equal to 3. So if you have a multiplied by b here, which is negative 2 multiplied by 3, here you are going to have negative 6. So in this case, we have a multiplied by b to be equal to negative 6, which is less than 0. Or the second condition, if you have a to be equal to 2 and b to be equal to negative 3. So meaning that b is less than 0, we are going to have again 2 multiplied by negative 3. Since we know that multiplication is commutative, this again is going to be equal to negative 6, and we have a multiplied by b to be equal to negative 6, which is less than 0. So we are going to be using this fact to solve quadratic inequality in one variable. So let's look at the first example. So before this example, I don't know, I'm sorry if you can hear my dog barking outside. So let's look at the first example. So the first one. So if you have to find the solution for the set x squared plus x minus 6 greater than 0. So here again we have a quadratic expression here, and we have this to be an inequality expression, and we have to find the solution to this. So the first thing we have to do is to find the root of the quadratic of, the first thing we have to do is to factorize this quadratic expression. So if you factorize this, we're going to have, I've not passed through the stages of factorizing a quadratic expression. So if you have little knowledge on that, you can check out my tutorial on how to solve quadratic expression. So to factorize this, we have x minus 2, x plus 3 greater than 0. So we now have our first case where we have a multiplied by b greater than 0. And from what we had in the first case, we have that if a multiplied by b greater than 0, then either of this condition must be satisfied. So let's test for the first condition. So a greater than 0 and also b greater than 0. So this a in this case, and this is b. So for the first condition, we're going to have a greater than 0, and this is going to be x minus 2 greater than 0, and then we have x to be greater than 2 if 2 comes to the right hand side. And also here we have b greater than 0. So here we're going to have x plus 3 greater than 0, and then we have x greater than negative 3. So we have two conditions here, x greater than 2 and also x greater than negative 3. So we can combine these two. Whatever is greater than 2 is surely greater than negative 3. So we can combine this whole expression to x is greater than 2. So that's the first case. So the second case we have to test for is this. So if I scroll back up, so we have to test by substituting less than in a and b. So we are going to have again a multiplied by b less than 0. We have x minus 2, x plus 3 less than 0. So again here we have a, and this is b. Let me scroll this down to have more space to work with. Okay, yeah. So again we have either a less than 0 or and b less than 0. So if a is less than 0, we have x minus 2 less than 0, and then we have x less than 2. So if b is less than 0, we have x plus 3 less than 0, and here we have x less than negative 3. So we have x less than 2 and x less than negative 3. So whatever is less than negative 3, we are sure that is less than 2. So we can combine this whole expression into x less than negative 3. So we now have two main expressions now. Here we have x greater than 2, and here we have x less than negative 3. So we can combine that. The solution to this quadratic inequality is simply x greater than 2 and x less than negative 3. So we have these two to be the solution to the quadratic inequality, x greater than 2 and x less than negative 3. So very quickly, if you have to show this on a number line, so I can just have my number line like this. So if I have this to be negative 3 on the number line, and I have this to be positive 2 on the number line, so I'm going to have everything to this side, and also x less than negative 3, everything to the left hand side. So this my point for x less than negative 3, and then we have x greater than 2. So this is how we can solve a quadratic inequality in one variable using the first method. So let's look at another example under this method. Second example, number 2. So let me have this here. So we have to solve a set of inequality, and we have the equation written as x squared plus 3x minus 4 is less than equal to 0. So here we have x. Let me rewrite this. So we have x squared plus 3x minus 4 less than or equal to 0. So this is where we have to consider that is the second expression where we have x a multiplied by b to be less than 0. So again, the first thing we have to do here is to find the root of this quadratic expression, or simply we can factorize this quadratic expression. So how do we factorize this? We are going to have the factors of this expression to be x minus 1 and also x plus 4. And here we have less than or equal to 0. So x minus 1 and x plus 4. So if you are to consider the conditions under the second statement, we have if a multiplied by b is less than 0, we can also put less than or equal to a. So then either we have a less than 0 and b greater than 0, or we have the first case. So again, if this is my a and this is my b, so the first condition is that either a is less than or equal to 0 in this case, because we have less than or equal to. So I will simply have either x minus 1 is less than or equal to 0, and then we have x less than or equal to 1. So this sums to x less than or equal to 1. And we have b. If you have less than a less than 0, we are going to have b greater than or equal to 0. So we have x plus 4 greater than or equal to 0, and here we have x greater than or equal to negative 4. So if you look at this, we have x less than 1 and x greater than or equal to negative 4. So this can be easily combined into a quadratic to a range. So if you have x to be less than 1 and x to be greater than negative 4, so we know that it starts from negative 3 up to 0. So we can combine this into negative 4 less than or equal to x less than or equal to 1. So you have negative 4 less than or equal to x less than or equal to 1. So that's the first condition we have to consider. So we consider the second expression where we have a to be greater than or equal to 0 and b to be less than or equal to 0. So again, if you have a, let me change this to, okay. Again, if you have a, I'm coming, okay, alright. If you have a to be greater than or equal to 0, so we are going to have a in this case, which is x minus 1 greater than or equal to 0, and then we have x greater than or equal to 1, and b to be less than or equal to 0. So we have b less than or equal to 0, and then we have b, okay, the statement for b is x plus 4 less than or equal to 0, and then we have x less than or equal to negative 4. So if you look at these two ranges very well, you see that x greater than 1 and x less than or equal to negative 4. So if x is less than or equal to negative 4, x cannot at the same time be greater than 1. So meaning that this particular two ranges cannot coexist. So we know these two ranges cannot coexist. Therefore, we have a single equation, which is a single range, that gives the solution to this quadratic inequality. And that is what we got in the first case, which is negative 4 less than or equal to x less than or equal to 1. And then we have the solution to this quadratic inequality. My negative 4 less than or equal to x less than or equal to 1. So how do I quickly show this in a number line so that you can visualize this? So if you have my number line here, I have negative 4 and then I have 1. So everything in this range symbolize the solution to my quadratic inequality. So we have x to be greater than 4 and x to be less than 1. So this is simply how you can find the solution to quadratic inequality using the first method, which we can simply refer to as the analytical method. So in the next tutorial, we're going to be looking at the second method, and also the following tutorial, we'll be looking at the third method. So that's it. Thanks very much for joining me in this tutorial. If you have any question, feel free to post it in the comment section below, and I will see you in the next tutorial. Thanks.